Hello friends, myself Mipal Parmar, and today here we are. I'm going to continue my last lecture, that is steam prime mover. In last lecture we have studied what is prime mover, what are the different types of prime mover, and then we have studied what is energy, and then what are the types of different energies or different source of energies, and then we have started the steam nozzle or functions of nozzle and the application of nozzle. Basically, in last lecture we have studied what is the function of nozzle, that is to convert the potential energy into the kinetic energy, and second, that is to guide the flow. In this lecture we are going to continue this topic nozzle by classifying the nozzle. What are the different types of nozzle? Basically there are three types of nozzle: convergent nozzle, divergent nozzle, and convergent divergent nozzle. Let us start with the convergent nozzle. In For the convergent nozzle, you can refer this figure. That you can see in this figure, your area is going to reduce continuously from the entry to the exit, or you can say the entrance to the exit. That means your entry area or entrance area is higher than the exit area. So such kind of nozzle or such kind of shape of the nozzle is called the convergent nozzle, which your cross sectional areas decreases continuously from its entrance to the exit. It is used in the case where the back pressure is equal to or a greater than the critical pressure ratio. Here we have a two term, that is back pressure and a critical pressure ratio. So let us understand what is back pressure and what is critical pressure ratio. Back pressure is nothing but your exit pressure at which your steam is coming out from the nozzle, and the critical pressure ratio is indicates that the pressure ratio after which the mass flow rate cannot be increased further even if the exit pressure is reduced. So on this critical pressure ratio we can easily define the what is critical pressure. So critical pressure is defined as the maximum value of the back pressure which gives you the maximum mass flow rate of the fluid. So it is called the critical pressure. That means इसको अगर हम सिंपल वे में समझने की कोशिश करें तो ऐसा maximum back pressure at which you will get the maximum mass flow rate. So if you reduce the further back pressure, you will not get the increased mass flow rate. So your mass flow rate remain constant at a back pressure. This is called the critical pressure. It is used for the non-compressible flow in a reaction turbine, or second, it is used for the subsonic flow. Subsonic flow, that means your Mach number is less than 1. Now we have to understand what is the Mach number. Mach number is the ratio of the velocity of fluid to the velocity of sound. Here friends, you have to tell me that what is the velocity of sound in comment box, and let us start the understand of the divergent nozzle. What is divergent nozzle? Divergent nozzle is completely opposite to the convergent nozzle. In this you can see your area is going to increase from the entrance to the exit. That means your entrance area is lower compared to the exit area. Here you have Mach number is greater than 1, while in divergent nozzle we have a Mach number is less than or equal to 1. Or there is a third one, that is convergent divergent nozzle. Convergent divergent nozzle is nothing but the combination of these two nozzles, that is convergent nozzle and second, that is divergent nozzle. Here you can see in the figure your first phase is that is convergent nozzle, or there is a second phase that is divergent nozzle, or in between this convergent and divergent nozzle, that convergent and divergent shape, there is a one part that is called the throat. In this phase there is a Mach number is less than or equal to 1, or in this phase you have a in a divergent section there is Mach number is greater than 1, or at the throat there is a Mach number is equal to the 1. That means at the throat your fluid flow velocity is equal to the sound velocity, as the Mach number we defined velocity of fluid to the velocity of sound. This is the case in you. So in let us understand what the definition is. In this type the cross sectional area first decreases from its entrance to the throat, and then again it increases from the throat to the exit, as I said. Basically this is used in the rockets where the high velocity is needed. So I have completed what are the different types of nozzles, that is convergent, divergent, and convergent divergent. In this in further remaining lectures we are going to study the calculation of the exit velocity in the nozzle, or how to calculate the mass flow rate to the nozzle. So in first, thank you so much friend, and stay tuned with me.